Okay, very quick supplemental video. There were two problems I wanted to do during class today, but ran out of time because Zoom school. So let's just do them now. I guess this is an optional. I'll make this video optional to watch because it's just kind of a repeat of some stuff we did during class, but it's sort of sufficiently different enough example that it might be helpful to some people. So here we go. Find the equation of the tangent line to f of x equals 1 over x at x equals 4. Okay, so let's again just do this, both ways, right? So what's the first way? Maybe I'll do these kind of simultaneously. The first way, and some people find this distracting, but I think it's better to just not bother trying to draw an accurate graph, but to just draw kind of like a generic sort of schematic of the whole situation. This is just to remind yourself sort of from scratch, from your own brain, what we're really doing. And the answer is we are starting at 4, and we are plugging in 4, and what do we get? Well, we get 1/4. And what do we want? We want the slope of the tangent line to the curve, so we pick a point x, and that's x comma 1 over x. Okay, well, we can draw the secant line through those 2 points, make the triangle. The triangle will have vertical component 1 over x minus 1 over 4, and horizontal component x minus 4. And so the slope of that blue line is 1 over x minus 1 over 4 over x minus 4. And what do I want to do? I want to move x infinitely close to 4. So I want to take the limit as x goes to 4. And yeah. Okay, I'll just say really quick that I always draw x on the right just by habit. But of course, when I write the limit as x approaches 4, I do mean that x is approaching 4 from the left and the right. So nothing should change if I happened on a whim to draw my x to the left of 4. The point x comma 1 over x, of course, would be the same, but I would probably flip both the numerator and denominator, so of course that doesn't change the fraction. So okay, this picture is fine though. Alright, so anyway, that's what I get. If I do that, then what do I have? I have this tangent line here, and I want to find the slope of the tangent line. Okay, before I actually do that limit, let's just do the other situation. The other situation is, logic is still the same, but the algebra is kind of different. Now I have my point 4, and this is 4 comma 1/4. But now this second point, it's a little bit crooked, my second point I now call 4 plus h. So this becomes, well, 4 plus h comma like 1 over 4 plus h, cha. And so again I can draw the secant line, and again I can draw in the triangle, and what do I have? I have x, or rather h, as my change in x, and my change in y is 1 over 4 plus h minus 1/4. Okay, and so what's the slope of that blue line? It's the change in y, 1 over 4 plus h minus 1/4 over the change in x, which is h, and now I want to take the limit as h goes to 0. Okay, so both of these should yield the same thing, and algebraically they're sort of, kind of different limits or something, but both should give the same answer. Okay, let's just do them. Here, what should I do? Well, it's a 0 over 0 situation, as every derivative is, but if I multiply this by 4 over 4, and this by x over x, and get a common denominator, that seems like the thing to do. So this gives me 4 minus x over 4x, and then that whole thing is over x minus 4. And so by simplifying the fractions, I get 4 minus x over 4x, x minus 4. Okay, probably showing too many steps here, but these are These two are opposites of each other, so they can cancel, leaving -1 left over, and thus this limit is, I think, pretty easy. It's the limit as x approaches 4 of -1 over 4x. Answer, therefore, -1/16. And over here, we have sort of similar work to do, I suppose. So here, if I want a common denominator, I'll multiply this by 4 over 4, and this by 4 plus h over 4 plus h. If I do that, then I guess what I get is 4 minus 4 minus h over 4 times 4 plus h, but then all of that over h. And if I simplify all that, then I get, maybe I'll do it over here, the limit as h approaches 0 of the 4's cancel, and I get -h over 4 h, 4 plus h. Of course, the h's cancel, and this therefore is the limit as h approaches 0 of -1 over 4 plus h. And when I plug in 0 for h, I get, again, -1/16. Okay, so maybe that was worth doing, I don't know. Let's just make an accurate graph now and take a look at it. So let's see, that's 1, 1, and by the time I get out here to 4, I am all the way down here at 1/4. And so I have something that looks like that. This is my curve, y equals 1 over x. And yeah, it seems pretty reasonable that the slope of the tangent line here would be -1/16. That looks about right to me. And this point is 4, 1/4. So therefore the equation of the tangent line would be y minus 1/4 equals -1/16 x minus 4, which is the actual answer to this problem. Okay, good. How much time do I have left? Yikes. I wanted to do one more thing that was a little bit harder. So okay, let me just erase this really fast. And the last thing we did in class was to talk about the derivative function, which is a function which outputs derivatives. Well, the one function that I wanted to do, but I decided there wasn't enough time, maybe, was this one, f of x equals root x minus 4. And now we're just told, yo, take the derivative. Okay, how do I find the derivative of a function? In general, well, once again, I make the picture because I'm a beginner. So I have a generic point x with coordinates x comma f of x, and then a point which is a little bit more than x, which I call x plus h, and yeah, so that's x plus h comma f of x plus h, and to find the slope of the tangent line to a generic point x, I draw the secant line, draw the triangle, and here we have f of x plus h minus f of x is the change in y, and the change in x is just h. That's why the definition of the derivative in general is f of x plus h minus f of x all over h, and we take the limit as h goes to 0. Okay, I like to kind of write that out like that every single time. That's just the definition. You could memorize it, but it's better to just understand via the picture. So make that picture every time on your paper, or perhaps just in your head or whatever. All right, how do we do it? Well, this is the limit as h goes to 0 of, what is f of x plus h? Well, it's like root x plus h minus 4 minus root x minus 4 all over h. And now, if I try to plug in 0 for h, I get that this is a 0 over 0 situation, of course, which every derivative is. But now, okay, it's a good thing we spent a whole 3.5 weeks on limits, because this is a relatively hard limit, I would say. And this requires that you have, more or less high levels of kind of experience and comfort with the algebra of solving limits. And okay, because that's true for all of you, then I think you will know exactly what to do here, and that is to multiply by the conjugate. So let's go. I'm going to multiply by root x plus h minus 4 plus root x minus 4 over root x plus h minus 4 plus root x minus 4. Okay, so multiplying by the conjugate is going to clarify things, but it's just a little bit hard. So what do we get? The limit as h approaches 0 of, well, it's a difference of squares in the top, of course. So that's x plus h minus 4 minus x minus 4. Maybe this is not so hard. I don't know. Okay, and then on the bottom I have h, and then just leave that. So that's root x plus h minus 4 plus root x minus 4. Alright, well when I distribute this through, I get minus x plus 4. So everything's going to cancel except for the h. So yeah, maybe this one's just not that hard. I take it back. I'm going to get an h on the top, and on the bottom, h times root x plus h minus 4 plus root x minus 4. And now what? Well, by multiplying by the conjugate, everything in the numerator now cancels, except for that h. The h's cancel, and so what I actually have here then is the limit as h goes to 0 of just 1 over root x plus h minus 4 plus root x minus 4. And that is now no longer indeterminate, so I can just plug in 0 for h. And if I plug in 0 for h, my answer is 1 over x minus 4 plus root x minus 4. And this can be just written as 1 over 2 root x minus 4. And so this is what we say is the derivative of this function. Okay, so that was a little bit of a harder example because it's not a polynomial. Can we make some sense of this? I think we can by graphing this function. So if I graph this function, what does it look like? Well, it's just a sideways parabola. So 1, 1, 4, 2. So we get something that looks like that. Maybe I'll even go out to a fake, 9, 3. And what do we have here? Well, this derivative formula, sort of like magic, is going to tell me what the slope of the tangent line is at all these points. So, if I plug in one... Oh man, I drew the wrong graph. Oh, I'm so sad. That was embarrassing. Sorry. So it's not 1, 9, 4. It's x minus 4, of course. So everything moves over 4. So it's 5, 1. It's 8, 6, 7, 8, 2. Right? Yes, of course. And I have to go all the way out to 13 to get 9? Yeah. So 9, 10, 11, 12, 13 gives me 9. Gives me 3, I mean. So, okay, there we go. Sorry about that. So 13, 3, 8, 2, and 5, 1. Okay, this should now make a little bit more sense. If I plug in 5 for x, what do I get? I get 1/2. Okay, so here is the line with slope 1/2. That looks about right. And what if I plug in 8 here? Then I get a minus 4 is 4, the square root of 4 is 2, so I get slope 1/4. Again, that looks about right. It does seem that the slope is getting smaller, but staying positive. That's not such a great tangent line, but okay, whatever. Finally, if I plug in 13, then I get the square root of 9, which is 3, so 3 times 2 is 6. So, okay, by the time I get out here, the slope is 1/6. Alright, so I think you appreciate the sort of power of having this general formula for the derivative, because it means that I can find the slopes at a whole bunch of different points once I get this formula. Okay, great. Goodbye.